Think we're live? I think we are live. Let's give it a minute. Let me pop out the chat. Also need to go live on TikTok. Boys, if anyone is already in the YouTube, if anyone's already in the YouTube, I've got the large data set just up, so it's subconsciously going into your brain while we just set up and wait a couple minutes before we get going. Hey guys, there is the large data set information just before we start. Just so it's naturally absorbing the large data set. But yeah, just gonna start TikTok live. Just give me a second, guys. I've got 5 or 6 questions today. We're gonna see how we go. Gonna do mechanics tomorrow, and then tomorrow evening I might do just stats or maybe a bit of stats and mechanics. A lot of rigid bodies. Got some projectiles for tomorrow. Also some rigid bodies. Wait, rigid bodies, projectiles. I've got trying to remember now. Some vector, position, acceleration stuff. I have Feather Pure one tomorrow, and I've been prioritizing that instead of mechanics. I mean, no mechanics. I assume you've done most of the past papers already. I'd assume so. That's ambitious. I mean, honestly, the mechanics is very repetitive though. So if you start like just doing as many questions as possible, you definitely can. You definitely can do it. Not gonna lie. Considering you've been doing all throughout the year. Cool. Starting TikTok live, guys. Remember, guys, with your UK locations on the large data set, it is alphabetical. I feel like a lot of tutors do say that, but it is alphabetical. Besides Heathrow, obviously Heathrow is in London, so it's not difficult to remember that. On what to start with, like with all of paper three. Um, if you haven't done anything, I don't know. It's quite a lot. I mean, there's certain topics that we do see coming up every single year. I'll put them up now, actually. Like these are the topics that we see by the year. I feel like a lot of you guys have seen this before, but every single year we see normal distribution. Every single year, hypothesis testing with normal. Some data set stuff. Yeah, guys, I'm not gonna do much Venn diagram stuff. No, I mean in the exam. Sorry. In the exam, no, whatever you want. I normally like just do it in order. Like whatever exam I'm sitting, I'll just do it in order. Yeah, it's been a while since I've done some mechanics, past paper questions, so I'm a bit rusty. I've got some topics. You do have time though. You do have time. I mean, what topics? What topics do you feel like in general with mechanics? I feel like rigid bodies tends to be something people don't like. But rigid bodies, there's always three things you do. Moments, vertical, and then horizontal. It's always those three things. Sometimes it can be a bit tough to like label your diagram, but once the diagram is labeled, it's just those three things on repeat every question. Guys, we're gonna start at maybe 8:06, like 2 or 3 more minutes. I'm gonna get the first question up. Sorry, guys. Do remember your large data set is from May to October. Okay, so that can I think we saw in the past paper that was a key mark that a lot of people missed. It's just like simple things that might help you with a large data set. Slopes. Mm. I've got a lot of hypothesis testing. I think, can you guys see on the right here? I've got hypothesis testing with our PMCC. I've got hypothesis testing with the normal, and then tomorrow we're doing hypothesis testing with binomial. We're doing it all. Any hypothesis testing you can think of, that's what we're doing. I'm gonna leave the first one up, guys. This is actually a 2024 question, the very first one. Just to start off with, everything else is non-past paper. This is the only past paper question. Can you do a Chem paper 3 live? I'm not doing a Chem paper 3 live. I have something, I can't even remember. But I'm not. I'm gonna do videos though. I'm definitely gonna do Chem Paper 3 videos. Most likely Paper 1 content because the Paper 2 stuff should be quite fresh. But yeah, yeah, a lot of hypothesis today. A lot of hypothesis. Gonna leave this question up if you guys wanna have a go. If you've already seen it, I apologize. But yeah, we're gonna start in 2 minutes. 2 minutes. Do you guys feel more worried about mechanics or statistics in general? Because I was gonna do two stat streams and one mechanics, but I could do one then 50-50. I can't on Friday, guys. For me, the A level season is done on Thursday. That's my ending for it. So while you guys are suffering Chem Paper 3, I think that's it for me. I will post a video or two, but then it's over. Summer, long summer, very long summer. But let's lock in for now. Let's lock in for now. We're gonna start in 1 more minute, guys. I'm gonna start going through this 2024 question. Stats is worse. Stats is worse. Stats because 50 out of 50 is So hard to get. Silly. Yeah, the large data set marks, always those like um all those wordy questions where it's like, why is this not appropriate? Why is it appropriate? But yeah. It's like just a minute, guys, just a minute. I'm seeing people don't like stats. Okay. I might just do the two stat streams then. Maybe one or two mechanics questions tomorrow evening. Alright. Let's get going. Let's get going. Alright. Everyone happy? Gonna make sure the stream is good before I start. I want to kind of do my explanation all at once. Top three papers you recommend to practice. I remember there was some pretty hard 2018 mechanics was kind of difficult, but okay, let's go. Yeah, we're told that Zhang Jian, however you want to say it, rolls a fair die 10 times. The random variable x represents the number of times the die lands on a 6. Okay, so we have a number of trials 10. We already have a probability. To land on a 6 faces, it's going to be 1/6 probability. So we already know that. So we're thinking binomial. Using a suitable distribution for x, find the probability that x equals 3. Alright, guys? So what do we know? So for a binomial, every trial must be independent. It's kind of a little bit of a recap because it's the start of the stream. Every trial must be independent. We have to have a fixed number of trials and fixed probability. Well, we have that fixed probability to be a sixth. And then we have that fixed trials. We have 10 rolls, so n is 10. And also two outcomes. We either roll a 6 or we don't roll a 6. It can either be a yes or a no, success or a failure. It's going to be binomial. So very easy. We set the probability that x equals 3. We have our distribution already. Binomial PD. Put it in your calculator. Your x equals 3. Number of trials is 10. And your probability of success is a 6. Obviously, you can do your 10 choose 3. A 6 times a 6 to the power of 3, 5, 6, or 7. Do not worry about that. Just put it in your calc. Yeah, okay, put it in your calc. You get 0.155. Okay. So we have the probability that x is less than 3, but remember, so we are going to have to use CD, cumulative distribution, still binomial, cumulative distribution, but less than 3. Remember, our calculator includes the x value that we put in, so probability that x is less than 3. This is discrete as well. We can either have 1/6, 2/6, 3/6s, 4/6s, and so on. So discrete values, binomial. X is less than 3. Because we have to include the value in our calculator, this would be the probability that x is less than or equal to 2. Exactly. Less than or equal to 2, the binomial CD, we have x equals 2, n equals 10, probability is 6. So this is the same as before. Put it in the calc, 0.775. I'm not going to waste my time with the calculator stuff, guys. I'll explain what to do, but then I'll just put the probability up, okay? I hope that's what you guys are fine with that. We're told, that Jean repeats this experiment each day for 60 days and records a number of days when x equals 3. Okay, so we still have a success or a failure. We have a day when x does equal 3 or x doesn't equal 3. Those are the two options. So we're still thinking binomial here. 60 days, so 60 trials. Okay, we have to find the probability that there were at least 12 days when x equals 3. Okay, so what do we have to do, guys? We have 60 trials, and we also have a probability. And it's a probability that we get 3/6s on a given day. Okay? So that's what we're going to do. It's still two outcomes. The number of sixes from 10 rolls is 3, or it's not 3. Still a yes or a no answer. So still binomial. We already know the probability that x equals 3. So that's a success probability where we see those 3/6s on a day. That is 0.155. You can store the answer with all the decimal places if you want to. The number of trials, well, we do this for 60 days. So we have a trials, we have a fixed probability. Perfect. We're going to define y to be the number of days where x equals 3. Okay, so the amount of days where we do see 3/6s. So we want the probability that y is larger than or equal to 12. Once again, cumulative distribution is the less than or equal to whenever we put it in our calc. So to find the probability that y is larger than or equal to 12, because remember, what did the question ask us? There were at least 12 days. So larger than or including equal to 12. So probability, there we go. So the probability, if it goes up, yeah, that y is larger than or equal to 12 will be 1 minus the probability that y is less than or equal to 11. We know that y is binomially distributed 60 days, 60 trials while we're doing this, with a fixed probability of 0.155. Put this in the calc. This gets you, so n equals 60, p equals what we found in part A, and our x will be 11 because we're trying to find this. So we get 0.788. We do 1 take away our answer, as we wrote out before, to get the probability that y is larger than or equal to 12. Remember, we do 1 minus, in this case, y less than or equal to 11, to get y larger than or equal to 12. And that gets you 0.212. Guys, let me know if I'm going too fast, too slow. Let me know. Let me know. I want to make sure I'm doing this at a good pace. So then we have to find an estimate for the total number of sixes that Jean will roll during these 60 days. Okay, so this is kind of unrelated to the distribution that we currently have. What do we know? There are 60 days, and we're rolling it 10 times each day. So the total number of rolls will be 10 times 60, right? Because 10 times every day, 60 days. So we're going to have 600 rolls in total. So we're going to make an expected value. So in this kind of, I wrote it out with the expected value. It should say y, good speed. Okay. So I've wrote, ignore this, guys, ignore this. So we're asking how many rolls do we have in total? 10 rolls a day, 60 days. We have 600 rolls. We know the mean will be the number of rolls multiplied by the probability. I believe this is in the formula book, but you can just think to yourself, I have this many rolls, what's the probability of seeing a certain success? In this case, to see sixes. So we do 600 multiplied by a sixth, because we would see a six 1/6 of the time. So 600 multiplied by a sixth is just 100. Very easy, it is just a one marker. It's kind of just a logic question, not to do with distribution. So for part D, here we go, lovely question. Use a normal approximation. So we know we're going to have to use that mu, or the mean, sorry, equals n times p, and our variance is n times p times 1 minus p. And you can square root that for the standard deviation. But let's just go through it step by step. Use a normal approximation to estimate the probability that Jeanne rolls a total of more than 95 sixes during these 60 days. So remember, guys, we currently have a binomial distribution. We're going to a normal distribution. What do we have to do? What do we have to do? Besides obviously converting the mean and the variance, what else do we, or creating the mean and the variance? What do we have to do? Let me know, let me know. I'm going to kind of start talking because the chat is delayed for me. I'm going to be doing this throughout. So I'll start talking and then look at the chat. Okay. So what we're going to do, we're going to find, we're gonna, nice intro to the paper, not gonna lie. Yeah. We're going to define T to be the total rolls of sixes. We're going to say that T is binomially distributed, 600 trials, a sixth each. So this is kind of using this part C here. Yep, I see it. I see everyone saying continuity correction. That's what we're going to have to do. We have our n, our number of trials to be 600 and probability to be a sixth. Now we know that our mean, mu, will be n times p, 600 times a sixth. We already found this in part C. That's just going to be 100. To find our variance, it's n times p times 1 minus p. Yeah, continuity correction is perfect. So we do 600 times our probability, which is a sixth, multiplied by 1 minus our probability, which is 5 over 6, 5 over 6, put it in the calculator, get 250 over 3 to be the variance, not the standard deviation, the variance. If we want the standard deviation, we're going to have to square root our variance, okay? So what do we currently want? So t, which is binomially distributed, we're still in a discrete, must be larger than 95, okay? But we're going from a binomial distribution to a normal approximation, discrete to continuous. So what we have to do, okay, I should probably scroll down. I just wrote L out of nowhere here. I'm going to define L for the normal distribution, and then the probability, we're going to have the probability, sorry, that L is larger than 95.5, because we're thinking, for a discrete one, you have to think, for T to be larger than 95, we must be larger than anything that rounds to 95, okay? So what would round to 95? 95.4999 would still round, I guess 95.5 would still round more or less to 95. You get what I'm saying? We have to be larger than anything that would round to 95. So our normal approximation must be larger than 95.5. We're going to define L to be the normal approximation. So as we said before, we had our mean to be 100 and our variance to be 250 over 3 using what they give in the formula sheet, or you could already remember it by now. Mean equals n times p, and so variance is n times p times 1 minus p. Make sure you guys know that going into the exam. It's definitely good for speed. So we want this. All we have to do is slap it in the calculator. It's normal CD. We have our lower, because we want the probability that's larger than 95.5. So our lower is 95.5. Our upper, a larger number, just 1, then spam a bunch of zeros. Yeah. We have our standard deviation to be the square root of the variance. Remember, the standard deviation is the square root of the variance. So plug all of this into your calculator. Lower, upper, mean, standard deviation gets you this probability. I believe in statistics, they're not so strict about whether it's 3 or 4 significant figures. You can write either one. In mechanics, it has to be 3 significant figures. In statistics, you can do 3 or 4. So we have 0.689 to be our probability. Guys, give me a thumbs up if that makes sense. Let me know if you have any questions. This is a standard normal approximation question. Some people were thrown off by this total number of rolls, but it's the same idea. I'm not going to do a Chem Paper 3 stream. I'm not doing it. Unless you guys just want more organic. I haven't prepared anything for that. But let me thumbs up if you're all happy with that. I'm going to put on the next question. I'm going to put on the next question if you guys want to start having a look at it. I'm sure a lot of you have seen questions like this from other maths tutors, maths YouTubers, just because we have a feeling geometric series might come up. I've kind of spoiled it, but I'm assuming you can spot that here. Pax is happy. Gonna make sure the stream's in good condition. Right, we are good. Alright, cool. Okay. Alright, let's carry on. So we have one of these discrete random variable questions. I already said at the top, try and draw out those probability tables. So we're told that Amira is practicing recalling digits of pi from memory. Okay. Each time she recalls a digit, her focus decreases slightly. Okay, fine. And she becomes less likely to recall the next one correctly. It's a bit of waffle, but let's see what the question is. Let a discrete random variable m. Wait, sorry. Can you explain to us quickly how you would decide what to do from the intro from last? Okay, yeah, I'll quickly go through that facts. From the intro of D. Can you please explain how you would decide what to do from the intro from last? So I'm trying to I'm not 100% sure what you mean, Pax. Use a normal approximation. Oh, the intro. Wait, I'm not. Sorry, bro. I'm not really sure what you mean. I'm not really sure what you mean by that. Well, I'll come back to it later, but I'm not. I'm a bit confused. Defining the total number of rolls potentially, because that's they were asking about the total number of rolls, not about on a given day or about the 60 days. If that makes sense. I'm just gonna carry on, guys. I'm gonna carry on. Okay, I'm just gonna quickly reread it again. Amira is practicing recalling digits of pi from memory. Each time she recalls a digit, her focus decreases slightly and she becomes less likely to recall the next one correctly. Let a discrete random variable m represent the number of digits she correctly recalls in a row. The probability distribution of m satisfies the probability that m equals n plus 1 equals 4/5 times the probability that m equals n. So the probability of the next number will be 4/5 of the previous, okay? So for n equals 1, 2, 3, and so on. Given that the probability of m equals 1 equals the probability that m equals 1 is h, we have to answer the following. So we have to show that the probability of m equals 3 equals 16 over 25. I would always recommend with these questions just writing out. Obviously, you want to write out your probability distribution table, but in general, maybe for part A, because it seems a little bit more tame, try write out a couple terms. Try write a couple terms if in doubt. Because we know the probability of m equals 1 is h. So let's just go from there using what they tell us. So exactly that. We know the probability of m equals 1 is h. We know the next one, so the probability that m equals 2 will be 4/5 times the probability that m equals 1. Okay, I shouldn't laugh at that. So we do 4/5 times the probability that m equals 1 for the probability that m equals 2. That's 4/5 times h. Same thing for the next number. The probability that m equals 3 will be 4/5 times the probability that m equals 2. We're just doing this every single time. Okay, so we do 4/5 times 4/5 h, 16 over 25 h. Okay, and that's the probability that m equals 3. So a quick one marker to start. Hence, we have to show that the probability of m equals n equals h multiplied by 4/5 the power of n minus 1. Does this make sense, guys? What we think when we see this? I mean, this looks like something that we know. I mean, I've said it already, but it's good to affirm these suspicions. So what does it look like? What does it look like? I'm gonna start going through it because the chat is it's like a minute slow for me. Oh, oh, oh. So in this case, exactly. In this case, it's a good idea to draw a probability distribution table. So we have to show that the probability that m equals n for a given n equals h times 4/5 to the power of n minus 1. So drawing out with the probability that m equals n. So sorry, at the top we have the different values that m can take. We'll call it little m because that's how we've defined it. So the values that a big M can take can be 1, 2, 3, 4, 5. We already know these probabilities for 1, 2, and 3. It's going to be h, 4/5 h, 16 over 25 h. Okay, perfect. Each time we're multiplying through by 4 over 5. Okay, so we're already recognizing here we're going to have a geometric sequence. We have a common ratio to be 4/5. We also know the first term. What else do we know? Well, the nth term of a nth term of a geometric sequence is a times r to the power of n minus 1. A, the first term, which we know to be h, and the common ratio are what we know to be 4/5. But what else do we need to know? What else do we need to know? Oh, so this is even for this question. So for this question, that's perfect. Using that geometric series nth term, geometric sequence nth term, we just plug in our first term h, our common ratio 4/5, and that's exactly what we have already. What we know to be the nth term formula. So that's perfect. But let's move on. I see some of you guys already seen that sum to infinity. We have to show that h equals a fifth. This is where we're going to use the sum to infinity. So we know that this relation is defined for n equals 1, 2, 3, all the way, yeah, all the way to infinity. Keep going and going and going. So we're showing that h equals a fifth. We're going to use the same idea. Use that probability distribution table. If you can visualize it, if you can see it, they may do these kind of questions with large data set values, for example. It may not be a geometric series, but it may just be something that you have to draw the table for and it helps you see it. So I'd always recommend to do it if you can, if it's a question like this. So from here, we're showing that h equals a fifth. So what do we know? So first of all, we can just write out all of the probabilities for each given term. We know it's 4/5 times the last one. There should be a h here and there should be a h here, guys. There should be a h on each of these two probabilities. What do we know? We know we have a geometric series or a sequence, but that will become a series. The sum of all the probabilities must add up to 1. Exactly. I'm seeing it. I hope you guys have seen questions like this before because there's a chance we see something like this potentially. I'm not going to make any predictions after paper 2, but you never know. So knowing this, we know that all of these terms, all these probabilities, sorry, will have to add up to 1. Because all probabilities must add up to 1. Because the probability that big M can be anything will be 1. So our ratio is 4/5. Our first term is h. We know the sum to infinity formula is a over 1 minus r. Plug it in. H over 1 minus 4/5, that's h over a fifth. H over a fifth is 5h. So we have 5h equals 1, h equals a fifth. I hope that's all good. Now we have to show that the probability that m is larger than or equal to 2, or we have to find, sorry, the probability that m is larger than or equal to 2 and less than or equal to 5. Stats questions do get repetitive. They do get repetitive. Ethan Cole, Ethan Cole doing statistics A level. Okay. All right. So all we're going to do, guys, is we're going to simply write out the probabilities for m equals 2, m equals 3, m equals 4, and m equals 5, and then we're going to plug in h equals a fifth. That's all it is. So we just write it out using that distribution table from before for 2, 3, 4, and 5. Remember, there should be h's here. Plug in the fifth. I'd say the fastest way in your calculator, would be to factor out the h, add up 4/5, 16 over 25, 64 over 125, 256 over 625, then multiply it by a fifth. It's just probably the fastest way. That gets you 0.472 to 3 decimal places, or 3 significant figures. So D's pretty easy. Guys, I want you guys to let me know what you would put for E. Explain why this model may not be suitable to describe a mirror's recall in the long term. One, you can do this, you can do. Yeah, once you can do this, you can do any question similar to this. Exactly. It's just about seeing it. Like, once you've seen it once, you now know if this comes up, you've got it. Let me know what you guys would put for this. There's a few things you could say, but these are the questions where you lose marks. This is like what stops people from getting 50 out of 50. Yeah, Fred's already got a good point. Like, would it actually, so in this case, remember what we're asking? It's for every digit of pi. She's recalling digits of pi, and we're saying it's less likely each time. Final answer for D? The final answer for D was 0.472, just by plugging in H into the probability for 2, 3, 4, and 5. It's discrete, so it can take values 2, 3, 4, and 5. Not independent. Yeah, exactly. I would say for E, that's a good thing to say. You can say anything logical. So exactly what you guys were saying. It's unlikely. Yeah, it's unlikely she knows all of pi. Exactly, that's a good assumption as well. It's unlikely memory decay decreases at a fixed rate, and in reality, she will not know every digit of pi with some probability. There's going to be some cutoff. Like, you know, it's going to be like 3.14, and then already there, there's a cutoff. You're not going to remember all the digits of pi. It doesn't account for that. So you can say either of these two things, they're both fine. You guys have mentioned both of them. Yeah, exactly. Perfect. I'm seeing all of you guys get these logic ones correct. That's good. The logic ones can be the hardest ones normally. Just gonna check the time. Looks like we're all good. Okay. Let's continue on. I'll put the next question up if you guys want to have a go. Got some hypothesis testing. I know you guys like it. Do you have any questions for given normal approximation and sample. I believe it's this, no? I believe this question has both of those. Let's check. Yeah, it does. I think it does, yeah. This is your no wait, is that normal approximation you said? For a given no given normal approximation. This isn't a given one, this is just a hypothesis test. There is a given in this question, but yeah. Has a bit of what you want. Just leaving it up for a second, guys. We start in 30 seconds. 30 seconds and I'll start going through it. Laptop's getting quite hot, just gonna check the stream condition. Okay, we're all good. Doesn't make sense, but normal is probably the easiest. I guess with the normal, you will be given the mean or the standard deviation. When you see you're given the mean or the standard deviation, it kind of implies it's normal. If you're not given the mean nor the standard deviation, you know you're going to go binomial. Because you already have these two distributions, depending on what they give you, you can almost immediately see what you're going to have to use. Okay, let's go. In a clothing factory, the time taken by machines to manufacture a certain type of shirt are assumed to be normally distributed with a mean of 44 minutes and a standard deviation of 4 minutes. Okay, so we give the mean and standard deviation, that's already quite friendly. Determine the value of t if 10.56 of the shirts take more than t minutes to be manufactured. So with these normal distribution questions, guys, obviously a lot of these, I assume you guys can do this instantly in the exam very, very quickly. But draw it out. If in doubt, draw it out. So we have x to be the time taken, that's what we're going to define our random variable x, normally distributed with mean 44 minutes, standard deviation 4, but remember we write it as the variance, so 4 squared. We're going to draw the curve to make it clear. So what do we have? We have the probability that x, the time taken, is larger than some unknown value to be 0.156. So let's draw it out. We have our normal bell curve, mean is 44, some value t, we're going to have 0.1056 area to the right of that. Okay, it can help, it can just help. So from here, we're going to use the inverse normal. But remember, guys, the area in your inverse normal is to the left. Okay? So because it's to the left, you're going to have to do 1 minus 0.1056 for the area that you put in your inverse normal. Oh, biology paper 3. Okay, yeah, that's tomorrow, isn't it? Yeah, yeah. Sorry, I forgot about that. So tomorrow is lock-in day for this stuff. Okay, cool. Okay. So anyway, we use the inverse normal. We do 1 minus this value. That gives us t equals 49. We have the mean, we have a standard deviation, and we have the area by doing 1 minus. Simple. Now, it's not in the long way, guys. I'll just go over the standardization. We do have the probability that x is larger than t to be 0.1056. So the probability that x is less than t, we do 1 minus that. So this is actually the area that we would have put in into our inverse normal. This is 0.8944. Then we can standardize. To standardize, with a probability that z is less than, so how do we standardize? We do our x value minus the mean over the standard deviation. That's quite important in many of these questions where you have an unknown mean, unknown standard deviation, or in this longer way. But we'll get there in a minute. I have an unknown mean and unknown standard deviation question. So we have the probability that z is less than, let's just call this some number for now, equals 0.8944. What we can do is find the inverse normal of 0.8944 to get the corresponding z value. So it gives us the z value such that the area to the left of it is 0.8944. We know this z value because it's the standardized, so our z value will be equal to t minus 44, so that's minus the mean over the standard deviation. Then to get your value of t, just multiply over by 4 and add 44. You could do it like this, but yeah, 3-4 marks, that's what we like to hear. So moving on, find the probability that a shirt picked at random took between 42 and 51 minutes to manufacture. This would not be 4 marks in your exam, guys. Okay, I'll tell you that now. So this is just putting lower and the upper in your calculator. We have the mean of 44 and the standard deviation of 4. Just plugging in numbers, guys. This is not so exactly that. The lower is 44, upper 51. Mean and standard deviation both given. We get a probability of, yeah, no, the marks is not real. 0.651. This is not from past papers, guys. These are other questions from, I don't even know if these are different examples. I assume it's different examples or international as well. Quite a few of them. But yeah. Yeah, yeah. These will be 1, 2 marks. Like these are not much. If a shirt, okay, here we are. If a shirt, they're giving us a requirement. Okay, what are we thinking? What are we thinking? They're giving us an if. What are we thinking, guys? Put it in the chat. If a shirt took less than 45 minutes to be made, so that's the requirement. calculate the probability that it in fact took more than 42 minutes to make. So I'm gonna wait till I see it in the chat before I address it. Let me know, guys, what we're thinking. If a shirt took less than 45 minutes, given perfect. So it's given that. So it's a probability that took larger than 44, given it's less than 45. Let's go through it. So it's giving us a condition, less than 45 minutes. We want the probability that is larger than 42 minutes, given that it's less than 45. Exactly. I'm seeing all the conditional probability. We have to recall the probability of A given B is a probability of A and B over the probability of B. Know this formula into your exam. You have to know it, guys. So we have, just plugging in what we currently have for this question, is a probability that X is larger than 42 and X is less than 45 over the probability that X is less than 45. So look at this numerator, we're larger than 42 and we're less than 45. So it's the probability that X is larger than 42, less than 45, over the probability that X is less than 45. In this case, it's just a case of lower and upper. Once again, in your calculator, normal CD. So yeah, we have the mean already to be 44, was it? Yeah, 44 and standard deviation 42. We know this already. So you slap each of these in the calculator. So less than 45, remember for that lower, you just put a really negative number. We have 42 and 45 for our lower and our upper. Then you just put these numbers in the fraction, put in your calculator. 3 or 4 significant figures, both are fine. Do 3 though if you're in doubt. 0.485. That's simply it, guys. There's a lot of calculator work here, but once you get it in this form, it's just using your normal CD. We know the mean, we know deviation, and all that. So I hope that's all good. I hope I'm not going too fast. Let's go on to the hypothesis test. I believe that's the next part. Okay, perfect. The owner of the factory believes the mean time is greater than 44 minutes. Guys, what are we thinking? One-tailed, two-tailed? What's happening here? It's greater than 44 minutes due to the aging machinery. He finds that the mean manufacturing time of a random sample of 4 shirts, okay, so we have a sample here, 4 shirts, n equals 4, to be 47 minutes, okay? So remember what hypothesis test is asking us, guys. It's asking us, so we have an original belief that the mean was 44 minutes. We're asking, based on some sample we take, is this value so extreme that our original assumption must be wrong? Like, is the likelihood of seeing these numbers in the sample so unlikely, so we're going to get such large, or in other questions, such small values, that we think there is no way our original mean was correct? That's what we're asking here, just to recap. One-tailed. Perfect. Everyone's saying one-tailed, that's what we want. So by clearly stating a suitable hypothesis, test at the 5% significance level, one-tailed, so we are going to take all of that 0.05 at one tail, because it's greater than 44 minutes. That's what we think, at least, of the owner's belief. Okay, guys. So we have our null hypothesis and our alternative hypothesis. Now, while I'm going through this, tell me what happens, guys. Because we have a sample, what's going to change in our distribution? So it's still going to be normally distributed, but what changes in the normal distribution? Write that down while I go through the first part, because it just takes a minute for you guys to see the chart. So null hypothesis, we originally thought that the mean is 44. This manager, or the owner, he believes that the mean is larger than 44 due to the old machinery. So null hypothesis, mu equals 44. Alternative, h1, mu is larger than 44. So I've already put it here, guys. I'm hoping I see it in the chat coming. Exactly that. Your variance will be divided, exactly, variance divided by the sample size, or standard deviation divided by the square root of the sample size, okay? One's just taking the square root, the same thing. So we have that x bar, so the sample, so the sample mean, x bar being the sample mean, is distributed, still mean 44, and we had the variance before to be 4 squared. We divide it by our sample size, which is n, because the sample that he took, those 4 shirts, we divided by 4. So what do we have? We have 47 to be the sample mean, and our variance will be 4. Because think about it, 4 squared is 16, divided by 4 is 4. Therefore, our standard deviation will be the square root of 4, which is 2. Okay? We're testing at the 5% significance level. So you can either find the critical region, or you can find the p-value. Guys, just get thumbs up for p-value, and smiley face for, I don't know, just tell me if you prefer the p-value or critical region. It doesn't matter which one you do. If it doesn't give you the standard deviation, which equation do you use to work it out? That's when you use your standardization. You have to use your standard normal in order to find an unknown standard deviation or an unknown mean. I'm going to do an example where we don't know either one later. Exactly. Hamza got it, yeah. Okay, so we see if the probability of getting this time is so unlikely with our current mean So we're checking, because it's one-tailed, we're checking the probability of getting this, given the mean of 44, and this standard deviation of 2 that we found will be less than 0.05. So we're checking the probability that x is larger than 47. So that's what we're checking. To get this value or anything more extreme, the lower will be 47. The upper will be just a massive number, standard deviation 2, and our mean is 44. It's not letting me scroll down. There we go. This gives us a probability. This gives us a probability of 0.0668. Pax-Like's critical region. We'll go over that in just a second. So this gives us a probability of 0.0668. This is a larger probability than 0.05. Therefore, we cannot reject our null hypothesis. The probability of getting this value is more likely than 5%, than 0.05. So because it's still not quite unlikely enough to reject what we currently have, we can maintain our null hypothesis. So we say there's insufficient evidence to reject the null hypothesis, or to support, we have to reference back to the question, to support the owner's claim that the mean time is greater than 44. Do you only check it's just above 0.95 with two-tailed? If it's two-tailed, this would have to be 0.025. You'd have to half it. The reason you half it is because you have to consider both extremes. It can either be way too small or way too large. But remember that total significance level must be equal to 0.05 if it was two-tailed. Here, because it's one-tailed, we take all of that significance level to one side because we're only checking about it being greater. Is the mean potentially greater because we're seeing such large times in this case? If you wanted the significance level, what you could do is, because we're taking the area to the left of the graph, not the right, you'd put in 0.95 as the area. Standard deviation would still be 2, and your mean would still be 44. And that would give you a value for the critical region. Let me try to put this up to the camera. Of 47, and it's mirrored 47.29, and that value is larger than 47. So our value isn't extreme enough to get, so it would have to be above 47.29. 47 is below that number, so we're not seeing something extreme enough to reject the null. Wouldn't the new variance be 1 squared? Sorry. 1 squared? We're not standardizing here. This isn't standard normal. We were just changing the variance. So 4 squared is 16, divided by 4 is 4. So the new variance is 4, and the square root of the new standard deviation. Seb, okay, I know Seb is not doing his A-levels, but no, with A-level maths, you have to reference to the context of the question. You do have to reference to the owner in this case. They always want you to relate back to the context. I'll put on the next question, guys. If you guys want to have a go at it. Let me know if you have any questions about the previous, or just any hypothesis test in general. So because remember, if the P is low, reject the hoe. Yeah? If the P is low, reject the hoe. I know it's a bit of a joke, but it is a good way to remember it. If your probability is so low, then you're going to reject the null. Seb's calm. Okay, cool. To be fair, because you said claim in that, there's a good chance they would actually allow it, to be honest. But I think if you just said to reject the null hypothesis, they wouldn't allow it. To reject the claim or the owner's claim, that would probably be enough, yeah. This is Edexcel statistics. Edexcel statistics. We're going to do some mech tomorrow and then a little bit more stats as well tomorrow. You use the big equation, probability of A or B equals A plus B and intersection B. Yeah, I mean, it's a good way to remember it. If the P is low, reject the hoe. Like it. I know people joke, but it helps. Okay, let's move on. So we're told the events A and B satisfied. Yeah, perfect. Hamza's on it. Probability of A equals X, probability of B equals Y. The probability of A or B equals 0.6, and the probability of B given A is 0.2. Seb, donate me £1 for every time I say probability. Show clearly that 4x plus 5y equals 3. So we're going to use the information that we have. There's a few things that we know. There's two formulas here that you have to know going into this exam. We have to know that the probability of A or B equals the probability of A plus the probability of B minus the probability of A intersection B. Think about your Venn diagram. If you want A or B, you take all of A you take all of B, but then you have to take away that overlap because you would be double counting. Okay, it's a good way to think of it, but just know the equation going into the exam. And we also know probability of B given A is probability of B and A over probability of A. Remember, whatever is the given part after the given part is in the denominator. So this is what we know. A or B equals the probability of A plus probability of B minus probability of A intersection B. Probability of A or B is 0.6. Probability of A is X. And then probability of B is Y. They tell us all this in the question. We need to find this probability of A or B. Because remember, guys, they're giving you information. If it's just to show that question, you just have to use what they give you. So we're going to use the probability of B given A is 0.2. Recall the formula, as we said, B given A is B and A over probability of A. We know this is 0.2. So what we can do is multiply over by probability of A, because we know the probability of A is X. We're trying to get everything, if I go back, in terms of X and Y. So this is good. We can get the probability of probability of B intersection A to be 0.2x by multiplying over by X, which is the probability of A. So we have 0.6, going back into this equation but up here, we have 0.6 equals X plus Y minus 0.2x. That's the intersection that we just found. So X minus 0.2x, that is just 0.8x. Let's compare to what we need. Our constant was 3. We currently have 0.6, so we're going to have to times by 5. Times everything through by 5 gets you the 3. 0.8 times 5, 4x. And then y times 5 is just 5y. Exactly what they wanted, guys. Let's move on to the next part. Yeah, Fred's on it. Cool. The events B and C are mutually exclusive. Guys, what does mutually exclusive mean? What does it imply? What does it imply? What does it mean? What does it mean, guys? Let me know what it is while I kind of read through. So the events B and C are mutually exclusive, such that the probability of B or C equals 0.9 and the probability of C equals X plus Y. Okay, this is good. They give us quite a decent bit of information here. So before I go down, I want you guys to tell me what the mutually exclusive means. Seb's on the TikTok as well. This guy. No intersection. Mutually exclusive. They're mutually exclusive, so if one happens, the other one can't happen. It's like if I breathe in, I can't breathe out, for example. It's a bad example, but those two things cannot happen at the same time. They do not meet. In the Venn diagram, they do not meet. Exactly. So if you draw the Venn diagram out, if one happens, the other one can't. There's no intersection. Mutually exclusive events will be drawn out like this on Venn diagrams. It's very important. So with the probability of B or C must be the probability of B plus the probability of C, sorry, because we know there's no intersection. So we know this when we know they're mutually exclusive. Now here's what we know. We know the probability of B is Y. We know the probability of B or C is 0.9, and we know the probability of C equals X plus Y. But we've established that this 0.9 must be equal to Y plus X plus Y. Okay? So we have 0.9 equals Y plus X plus Y. Therefore, 0.9 will be equal to, add the y's together, 2y plus x. Okay? But we also have another equation with x and y's, because we're trying to solve for x and y, guys, right? Let's look at the question. We want to find x and y. Oh, we have two simultaneous equations. We can use that. Perfect. Okay? So we have this one simultaneous equation that we just found now. 0.9 equals 2y plus x. And we have 4x plus 5y equals 3. Amazing. Yeah? Solve it in. Obviously, solve them however you want, guys. It's GCSE simultaneous equations. I'm going to just do it by substitution. I'm going to take away 2y from my 0.9, so I have that x equals 0.9 minus 2y, and then I'm going to plug in this substitution for x. So I have 4 times 0.9 minus 2y, 4 times 0.9 is 3.6, 4 times minus 2y is, 4 times minus 2y is minus 8y, plus 5y is minus 3y, that will be equal to 3. So from here we can rearrange for y, add over the 3y, 3.6, take away the 3. We have 0.6 equals 3y. Divide over by 3, we have y equals 0.2. When we see y equals 0.2, we are quite happy because we know our probability must be larger than or equal to 0, or less than, well, it has to be less than 1 in this case. So 0.2 looks about right. Now we plug in this y. We can just plug it into any equation, but let's just go here. It looks easy. So we have 0.9 minus 2 times 0.2. So that's 0.9 minus 0.4, which will be 0.5. So x is 0.5. How do you gift it, bro? Seb, you do not need to gift. You can smash subscribe, that helps. But you don't need to gift. Don't need to gift, Seb. Okay. So from here, so we found x and y. Determine, showing all the relevant workings, whether A and B are statistically independent. So what do we know, guys? What does it mean if they're independent? What does it mean? What is the equation that we need to know that tells us if they're independent or not? Gonna wait 30 seconds. Gonna wait 30 seconds. Actually, I assume you guys are writing it out already, so I'm gonna just explain it and then I'll see the chat after. So there's two ways you can actually do this, guys, but obviously there's one main way that they want you to do in your exam. So we're gonna check if the probability of A multiplied by the probability of B equals the probability of A intersection B. This is how we check independence. If this is true, then they're independent. Okay? So probability of A is X, I believe, and probability of B is Y. I'm just gonna quickly check that. Okay, A is X, B is Y, yeah. So probability of A equals X, probability of B equals Y. We know these now to be 0.5 multiplied by 0.2. And then we have probability of A intersection B, they told us at the start to be 0.2x, or we found at the start to be 0.2x. So we have 0.5 times 0.2 equals 0.2, and then x is 0.5. We can already see these are going to be the same. So we have 0.1 equals 0.1, therefore they're independent. Everyone's happy, yeah, everyone's happy. Probability of A intersection probability of B equals probability of B. Yeah, okay, probability of A times, yeah, cool. Perfect, yeah, perfect. Everyone's happy with that. The other way you could do, guys, is because we know the probability of B given A is 0.2, and this equals the probability of B. Because the probability of B equals the probability of B given A, it means that A has no effect on B. Because the requirement of A having happened or haven't happened has no effect on B. So that's another way you could say it's independent, but don't do that in the exam. Do this in the exam, okay? That's just one other way if you're curious, but definitely do this way in the exam. I've got two more questions for you guys. Not a long stream, probably be like an hour 10, hour 20. It's a bit of hypothesis testing with our product moment correlation coefficient, or PMCC. I'll leave it up for 30 seconds. Just you guys, actually, I'll read it through. By the way, guys, I believe they will give you less values for your x's and y's because with this question, you're going to have to use your calculator. The statistics section, that's on 6, and then you're going to use 2, and then you have to fill in all of your x's and all of your y's, then do option 4. We're going to do two more questions. One of them is going to be an unknown mean, unknown standard deviation question. All right, so question 3 of this paper. An electrical appliances supplier wishes to investigate the impact of advertising on the sales of his washing machines. Remember, guys, this might be relevant for your final context at the end of the question. He records the number of monthly advertisement placed on the local radio station and the number of washing machines sold. Cool. This is a table of his results. So we have our advertisements X. It'll even give us X and Y. Amazing. So you have all these values and the number of washing machines sold. Well, I can already see, like, when we have these larger advertisements, we do tend to see slightly larger numbers. Nothing crazy, nothing obvious. But don't worry about that. Test at the 10% significance level whether there's evidence of correlation between X and Y. Guys, right now, one-tailed or two-tailed? And explain what conclusions the electrical appliances supplier should make from this value. Okay? So one-tailed or two-tailed, guys? One-tailed or two-tailed? I'm gonna wait before I start going through. So remember, guys, for this, you go to the statistics section, you plug in all these values. They'll give you less in the real exam. This is one of those like practice questions where they just take the piss a bit. So you plug in all these values, you do option 4, I believe, for your regression calculation, and it will give you that R value. Okay, I'm not going to spend that time doing that now. Okay, everyone's saying two-tailed. Perfect. Why is it two-tailed? Because we're asking if there is any correlation. We're not asking if it's positive correlation. We're not asking if it's negative correlation. We're just asking if there's any. So it's like when people say, is there a change to this mean or is there a different mean? Same idea here. If there's any correlation, we're asking about correlation. It can be negative or positive. So we're testing both sides. So because we're testing at 10% significance level, that means we're going to designate 5% to one side, 5% to the other, because the total must be equal to 10%. Okay? So what we do, plug everything into the calculator. Here is a data sheet, guys, that we are going to have to use. And because we know the relevant significance level that we're going to have to use is half of that 10%, so 5%, it will be the 0.05. Furthermore, quickly counting the number of samples, that's 3, 5, 3, 5, so we have n equals 10 in total. So we know we're going to have to go there. We actually can already see, going to the sample size of 10, a significance level of 0.05, we're going to have 0.5494. So I'm going to go through the question now, but we already know we're going to have that value. to check whether R1 is larger than or less than it. Remember, it's the modulus of our value in case there's a negative correlation. But let's just go step by step. So for the PMCC, use your calculator, stats section gives us an R, or the correlation coefficient, of 0.817. The significance level, 10%. We're testing if there's any correlation. So our null hypothesis will be that rho equals 0. It's always going to be this for these questions. Always going to say the null hypothesis is that rho equals 0. No correlation. Alternative hypothesis, in this case, because it's positive or negative potentially, we're going to say that rho does not equal 0. Our sample size is 10. Using the tablet, oh yeah, okay, tableau maybe I meant to say, I don't know. Using the table in the datasheet, we use that significance level of 0.05, sample size 10, and it gives us 0.5494. Now we're asking, is our correlation stronger than that value? If it's stronger than that value, whether it's positive or negative, then we believe there is a correlation. We reject the null hypothesis and we say there is a correlation. Now we can see our value is more positive. If this was a negative value, guys, you would take the negative version of 0.5494, or you could do the modulus of your value to suggest there's correlation. But if ours is negative, remember the closer you get to -1, that means complete negative correlation. So if we had minus 0.187, there'd be a very negative correlation. But because that is more negative, or the modulus of it is more positive, either way, than 0.5494, you can kind of think of it as a stronger correlation. We reject the null. Yeah, ignore the marks. Ignore the marks for these questions. So we know that 0.817 is larger than 0.5494. Therefore, we have evidence to reject the null because we see correlation, in this case, positive correlation. Okay? You got 0.810 for the R value. I don't know why I got 0.817. I mean, either way, guys, we're rejecting the null hypothesis. Maybe I typed in a number wrong when I did this. I kind of just saw this question and gave it a go myself. Maybe I put something in wrong. But either way, 0.810, 0.817 is going to be larger than 0.5494. So there is evidence. There is evidence for a positive correlation. So what's the conclusion? Because remember, guys, they wanted us to link back to the context. Also, in the exam, guys, be careful plugging in your numbers. But yeah, so explain what conclusions you can make. What's the exclusion we can make? A conclusion we can make. There's a positive correlation. So therefore, my one's correct. My one's correct. Oh, it is okay. Okay. All right. I mean, either way, don't stress too much. This is the revision time. In the exam, you guys are going to be so locked in plugging those numbers if they give you this kind of question. So what do we assume? The more advertisements we have, the more washing machines that we sell. So therefore, if we place these advertisements on the local radio station, it has that desired outcome of selling more machines. So that's what we say. As there's evidence for a positive correlation, placing ads in the local radio will increase the sales. Okay? That's it. Nothing scary. That's all it is. Let's move on. All right, boys. Unknown mean and unknown standard deviation. Good questions, these ones. Good questions. These are quite good. Give you guys a second to read it through. It's the last question of today. Not a long stream, just over an hour, I reckon. But yeah. And guys, at the end of the stream, or even put it in now, are there any statistics or mechanics topics that you want me to cover for tomorrow? And I also wanted to ask for mechanics diagrams, because I have to pre-write it out because I don't have OneNote or a pen, so it would be very messy if I did it live. Yeah, Pax is already there. It would be messy if I did it live. Would you guys want me to put my notes on OneNote and then as I'm explaining, kind of highlight the forces that I do, or are you guys fine with just the cursor for me to show? So any topics, and let me know if you want me to highlight forces as I talk about them on my diagrams that I make or that I have pre-prepared. So let me know both of those things, guys. Let me know both of those things. Question 2. What was question 2? The discrete distribution. Yeah, I'll get some questions on that. Don't worry. Definitely will do some of those. All right. Just gonna give it 30 more seconds before we get going. If you guys want to have a go. All right. Let's go for it. So we are gonna have to standardize in this question. You guys are correct. That's what we're gonna be doing. Chat is very slow for me. I apologize. Moments. Yeah, I got some moments questions already prepared. You know the hinge today. If it was roughly hinged, would the frictional force be the same as the vertical reaction force? If it's some rough, you would still put that force the same and label it y. Normally, because it's frictional, they'll normally ask later on in the question about your coefficient of friction, and then you have to relate it to that reaction force. that's pushing into the beam, okay? So it is still the same kind of reaction force going up or down. We can find out at the end of the question whether it's positive or negative. I made the video on it, but yeah, it's still the same place. I got some questions whether it should be up by the rope or anything. No, it's not going to be there. It's still going to be at that hinge. Moments lift. You want a lift example? Lift is year one. I was surprised about I saw quite a lot of people wanting lifts as well. So I might do a question on that. I might. I do want to prioritize year two stuff just because I know a lot of people also want year two. Next time, are you able to keep the question in the frame while showing the solution? Can't really, but okay, let's just go through this question, guys. I've got loads of moments, rigid bodies, projectiles, connected particles. I've got all of that for tomorrow. So yeah, static rigid beads, or like pegs and stuff. I've got a ladder question and I've got a hinge question for tomorrow. So it is the 2018 hinge question. I just think it was quite a good question. Two, yeah, you can draw it as two. I've heard different teachers explain different things, but mechanics 3 might be a bit longer than this one. Let's go through this question now. The weekly mileages, sorry, of a sales rep are thought to be normally distributed with mean mu and standard deviation sigma. We don't know mean or standard deviation. Unlucky. 5% of his weekly mileages are less than 850 and 1% exceed 960. Find, correct to the nearest mile, so the nearest mile, the value of mu and the value of sigma. Sorry. Okay, so what are we going to do? I'd always recommend to draw it out. I'd always recommend to draw it out. So what do we have? We're going to call X the weekly mileages. I'm going to say it's normally distributed with mean mu and variance sigma squared or standard deviation sigma. Draw it out to help. So ignore this. This is just waffle. This is just the probabilities. I've kind of just put them approximately in just for the sketch. Okay. So we have that 5% is less than 850. So we can draw 850 down here because we know 5% is less than it. So we have this area to be 0.05. Then we know that 1% is more than 960. So we can draw a 960 here. And we know that area is 0.1 over that. So what we have to do is use a standard normal. We know that z, once again, standard normal, equals x minus mu over sigma. Remember, our standard normal z has a mean of 0 and a variance of 1. Okay. So here's what we're going to do. We're going to find the corresponding z values for these given areas. We're going to use our inverse normal, okay? Because we know the mean and we know the standard deviation for z. So what we can do, plug in 0.05 in our inverse normal with this mean and this standard deviation, 0 and 1. That will give us the corresponding z value to be minus 1.644853667. And then, because remember, inverse normal gives us the area to the left, we're going to plug in 1 minus 0.01. So we have 0.99 to find the corresponding z value, which would have 99% or 0.99 to the left of it. Okay? That gives us 2.32634791. Just try write as much as you can to make your answer accurate. Pax is saying 901. Unless I didn't get 901, but let's go through it. So we have that using the z equals. Oh, did I write the question out wrong? 850? 850? No, that's fine. Okay. So we have the minus 1.644853667 equals. So remember, to get the z value, we had to standardize. So it's going to be 850, because remember, that's the corresponding x value to the z value. So we have 850, take away the mean over the standard deviation. And then we have, for our other one, with 0.99, with this corresponding z value, with 0.99 area to the left, we have this z value to be 960, take away the mean over standard deviation. Take away the mean over standard deviation. Has to be in your head in these exams. So remember, with these kind of questions, we create simultaneous equations. We multiply over by the standard deviation on the left-hand side. So we have, I'm not going to write it all out, I'm not going to read it all out, but this 1.64 equals, or sigma, sorry, 1.64 sigma equals 850 minus mu, then 2.33 or 2.326 equals 960 minus mu. We have simultaneous equations. Solve them however you want to, guys. The way I'm going to do it, so I'm going to do 2 minus 1, so our mu's will cancel out. Minus mu, minus mu, so that's adding mu, those cancel out. So doing that 2.32 minus 1.644 will give you 3.97120159 sigma to be 110, because 960 minus 850 is 110. What we can do here is do 110 divided by this big number here, 3.97, to get us 27.699. 42479, okay? So to the nearest mile, remember they wanted it to the nearest mile, so it's going to be an integer. We round this, it gives us 28 for our standard deviation. Is everyone happy? Yeah, I'm seeing people get the right stuff here. Okay, so we know this is that, let's just say 27 point, okay, so we use the standard deviation of 27.6. That should not be a point there, 27.699, the value we had before, because we don't want to use this rounding to find mu. We want to keep it unrounded for mu, okay? If you round it and then put it in, it can give you a wrong value. It might not in this case, but always be careful with that. So you can plug it into either equation that we had before. So we have our standard deviation. So let's just say that mu equals, add it over, then, so which one did I use? I did 960, then I took away this 2.326 times by sigma, using the value of sigma to be 27.699. So 960, plug in the calculator, guys. We know the value of sigma. We get mu equals 895.56. Nearest mile, we round it. So 0.56, we're going to round it up to 896 to be the nearest mile. 896 and 27.7. Okay, yeah, perfect. So remember, nearest mile would be 28 for that standard deviation, but yeah, you guys got the right numbers. Is there any more to this question? There is indeed. Okay, guys, now we have the rep, believes that the value of mu is much lower than the one found in part A, based on a random sample of four weeks whose mean mileage was 863. So what are we thinking? He believes that mu is lower, one-tailed or two-tailed, guys, one-tailed or two-tailed, based on part A. So he's doing a random sample, so n equals 4, again, in this case, n equals 4, and we're saying the sample mean was 863. So what are we asking? We're asking, is this value so extreme or so much lower that we're going to reject our original distribution? Is this value that we found so much lower that it's so unlikely to happen given our original distribution? Pax got it, one-tailed, perfect. So is this so much less than 800 and what do we have? What was I mean before? 896, I believe. Yeah, 896. Is it so much less than 896 with that distribution of mean 896 that we're thinking, okay, maybe our distribution shouldn't be or is not correct, so we're going to support the manager's belief. So that's what we're asking, okay? So same idea as before, guys. It's a hypothesis test at the 1% level. Remember, you can use the p-value or you can use the critical region, okay? So let's state our hypothesis. The null hypothesis is always just the current value of the mean that we have. So h naught is that mu equals 896. Our alternative, what the rep is proposing, his hypothesis, is that mu is less than 896. So remember, guys, our sample, so x bar, will be distributed normally with mean mu, the mean stays the same. But then our variance will be changed to sigma squared over n. We divide by n of our variance, therefore we divide the standard deviation by root n, just taking the square root, okay? So we have n equals 4, x bar equals 863, and our standard deviation equals 28, using our values that we found for part A. If you didn't find these values for part A, it is error carried forward, don't stress too much. So 1% significance level, one-tailed, we take all of that 0.01 to that area beneath, okay? So we're asking, is the value that we got so unlikely given the original distribution that that probability of getting that value is less than 0.01? That's what we're checking, okay? So we're checking how likely it is to see 863 given our current mean. So for the p-value, we use our normal CD. We have mu to be 896. We have our standard deviation to be 14. Why is it 14? Because we knew our original standard deviation was 28 from part A. And then taking the square root of n, we had n equals 4. That's our sample size. Taking the square root is 2. So we have 28 over 2. That's just 14, okay? So this is what we plug into our normal CD. Our upper be 863 because we're trying to see the probability being 863 or anything less, okay? That probability will be 0.009208, which is less than 0.01. Therefore, there is sufficient evidence to reject H0. Remember to relate back to the question, but I'm just going to do the critical region way quickly. The critical region, what you would do, same idea, mu equals 896, sigma equals, or standard deviation equals 14. You plug in that area of 0.01. Because we're looking at that less than already, we can just plug in 0.01. We don't have to worry about doing 1 minus. 1 minus is if it's the area to the right, so we're looking when it's greater than. When it's less than, we can just use that 0.01 already. So plugging that into our inverse normal, same standard deviation, same mean. This gives us a value of 863.431129. So if we see anything of 863.431129 or larger, that's still within our acceptable region. Anything more extreme than that, so more negative, makes us think, okay, our null hypothesis is a little bit little bit wrong here. We're seeing two extreme values, so we're going to have to reject the original distribution. So because this lies in the critical region, you can just say we reject the whole null hypothesis and we have evidence to support the rep's belief. If you want to get specific for the context, you can say we're supporting the rep's belief. That's already good, but you can say that we have a mean mileage, a lower mean mileage, okay, or lower mean mileage. Yeah. So yeah, that's it, guys. That is it. I hope that makes sense. Give me a thumbs up, and guys, let me know if you want me to, or what topics you want me to cover tomorrow. It looks like I have most of the ones that people want with rigid bodies and um yeah, rigid bodies, projectiles, connected particles, hinges, all that stuff. So yeah, let me know, guys. And I think that's all the questions I have for today. Let me know if you have any questions about anything. But yeah, I'll leave up this large data set just while I could I give you a question with unknown mu and sigma, but they count this by using a sample. But they count this by using a sample number. Not 100% sure what you mean. I will say because sometimes they give you the true. Yeah, so would you say it's worth to know both methods or just probability as it is quicker and easier? Know both methods because they may ask you for a critical value or they may ask you for your total actual significance level. Remember, your total actual significance level, you have to take the actual probability of your two critical region tails and add them together. Okay, so it's definitely you have to know the value. You have to know how to do the p-value. I hope this was helpful, guys. Okay, I got a very specific type of question. Can I send it to you? It comes under force dynamics. I mean, yeah, go for it. If you have a link or something, always message me on TikTok or anything like that. Yeah, I hope this was helpful, guys. I hope this was helpful. Coding is just using a formula. It's in the textbook. Like, I haven't actually looked at coding in a while because most people just say it's just applying the formula. I'll check that definitely. I'll definitely mention it tomorrow, but maybe put up a question tomorrow. I believe it's just the formula, isn't it? Like, guys, I have missed out a lot of key questions in mechanics and statistics that are just tend to be using the formula. Like all this like data collection stuff, I do. I'm just gonna skip it out because a lot of it is just plugging stuff in. I want to do the stuff which is more conceptual and potentially a bit harder. So mechanics 10 a.m. tomorrow. Just gonna leave the stream up for 1 more minute. If anyone has any questions or any topics they want, for the two-tailed hypothesis test with a sample number. Yep. Could do ask to find out mu and sigma of the original? I haven't seen a question like that. I'm trying to think. So what? They give you the sample number. Cool. 12-hour stream. Yeah, I don't know how Neil does maths is doing that. Let me think about that. They give you the sample number. Then you find your values given. They wouldn't do that though. That's the thing. They wouldn't. I don't think I've seen a question like that. If you find the question like that, I'll go through it. But I don't think they would ever give you a question like that. But you have to use your sample because the whole point of the sample is to disprove your original distribution. And if you're basing it off the sample to find the original, I mean, I guess they could ask what was the variance originally, and you would just times it by n, I guess. But that's all I can really imagine. 12-hour stream tomorrow. You know what? But Neil does maths. That's a full-time job for him. That's 12-hour stream, was it 9 a.m. to 9 p.m. Guys, please join my stream just for like if you want a little break from Neil's, I don't know, his presence. Feel free to come here for just an hour. If you guys want any more questions, we are done. I'll leave this large data set up for just for 2 more minutes, and then we'll end the stream. Force statistics 10 marker. I sent it to you. Can I possibly go through this too tomorrow? Okay, yeah. Yeah, I'll look at that question and see if it's anything bad. Love my videos. Yeah, I hope the videos are helpful, guys. Smash subscribe if the videos are helpful. Okay, perfect, guys. No, I mean, Neil does maths. The thing is, the way I'm going to explain mechanics is going to be very similar to the way Neil explains mechanics. Because when I did my A levels, I found, for example, when he draws those forces with long arrows and like crosses off the forces as he goes, like I do it the same way. So it's kind of like we will be going through very similar ways of doing it. So I guess you're not really benefiting either way. Either way, I'm going to try help. He's going to try help. But I like his approach to those questions, so I approach them the same way. I appreciate that, guys. I hope the questions are helpful. I hope the stream's helpful. I think I'm gonna end it there, guys.